Okay, here's 10.4, inscribed angles. Objective, Buckingham students will find the measure of inscribed angles and find the measure of angles and of inscribed polygons. Okay. Alright, so inscribed, this means to be touching and inside another shape, and circumscribed means to be touching and outside another shape. Alright, let me give you guys some drawings of what this means. Let's say I wanted to do inscribed first. Okay, inscribed would be like this. I have a circle. I know it doesn't look like a circle, but trust me, it's a circle. And I have a triangle that is inscribed that circle, or inside that circle. Okay, circumscribed would be like this. Now I have a circle and I have a triangle that is circumscribed about that circle. Notice I know my drawings are not perfect, but now I have a triangle that goes on the outside of this circle, and here I had a triangle on the inside. So inscribed, inside, circumscribed is outside. Okay, that's the basic definitions that you just need to get down. Alright. So we're going to mainly talk about inscribed things today, like an inscribed angle. And we have here an inscribed angle theorem, which says if an angle is inscribed in a circle, then the measure of the angle equals 1/2 the measure of its intercepted arc, or the measure of the intercepted arc is twice the measure of the inscribed angle. Here's the idea. An inscribed angle is any angle that is touching the inside of this circle and yet opens up to some arc. So here you have P, it's an inscribed angle, and it hits A and it hits B, making this arc AB the arc that it intercepts. So whatever AB is, this angle P is half of AB. Or you could say twice angle APB, or just angle P, equals AB. So this is going to be half of this measurement and half of this measurement, because remember, arcs and central angles are the same. So that's why we know it's half. Okay. So let's use that and go on to the next example problem. So we have example number 1 here, and it says in circle O, which is the circle here, O is the center, we have arc AB, which is 140, and arc BC, which is 100. So let's kind of write that in here. This is 140, and BC is 100. Now right away you may see, well, hey look, AB looks like it's smaller than BC, and BC looks like it's bigger than AB. How is it this 140 and this 100? Remember, nothing is drawn to scale here, and a lot of times in geometry things are not going to be drawn to scale, and we have to trust the numbers, not the drawing. Okay, then it says arc AD is congruent to arc DC. It says find the measure of each of the numbered angles. Okay, I'm going to zoom in now. Now that we have everything marked, let's zoom in. Let's talk about this problem. We should be able to find all the missing angles, all the angles numbered here. Let's start. I'm going to actually start with angle 3. And I'm going to draw this out for you. So you see angle 3 is right here. It's the angle that's boundaried by the red lines. And it has this arc. Well, we know the arc that it intercepts is 100. And that theorem we just learned says that means that this angle must be half of 100, or 50 degrees. And so we can actually use this to find lots of information here. I mean, look at angle 4. 4 hits this angle, which is 140. So 4 must be half of 140, or 70 degrees. And 5, look at 5. 5 also hits this arc that's 100. So 5 must also be half of 100, or 50 degrees. Now for angles 1 and 2, we have a problem. Well, 1, we see that 1 and 2 both intercept this arc, and 2 intercepts this arc. So they intercept congruent arcs. So whatever this arc is, 1 is going to be half of it, and 2 is going to be half of it, and they're going to be equal because they're both going to be half of the same arc. But we need to figure out what that arc is first. All right. That's not a problem because I have 140 plus 100, which is this part over here. And then I have 2 parts that are equal. So I'm going to actually just call these parts x and x for the time being. And I know that all of those arcs have to add up to 360. And then from there, I'm just going to do some algebra. 140 plus 100 is 240. Plus 2x equals 360. Subtract 240 from both sides. And I'm going to get 2x equals 120. And divide by 2, I'm going to get x equals 60. Okay, so this is 60 degrees, and this is 60 degrees. Well, that means then angle 1 is the inscribed angle that intercepts this arc that is 60. So what is angle 1? Well, it must be half of 60, so it's 30 degrees. And the same thing is actually going to be true of angle 2 because they both inscribe arcs that are 60 degrees. Okay, that's how you do a problem like that. All right, let's look at the next theorem here. And I apologize, it looks like there's some glitches in my notes here, but as we zoom in, we'll see they go away. Okay, theorem 10.6 says that if 2 angles of a circle, if 2 inscribed angles is what we're looking for there, of a circle or of congruent circles intercept congruent arcs or the same arc, then the angles are congruent. Okay, this is what we're saying. Let's zoom in on our picture. I have an intercepted arc here by angle A. It intercepts this arc. Angle B intercepts this arc. Since they both intercept the same arc, kind of like we had in the previous problem, that tells us that these 2 arcs are the same. And then this arc here, you notice, is intercepted by that angle. And let's do a different color and bolden it by that angle. So we know these 2 angles must be congruent as well because they both intercept the same arc here. Okay. Now, this next problem, I'm going to leave it a little bit zoomed out. It says points A and B on a circle so that AB is 60. Suppose that point D is randomly located on the same circle so that it does not coincide with A or B. So it's not on top of A, it's not on top of B. What is the probability that angle ADB is 30? Well, what we need to know in order to solve this is where on this circle will D make this angle 30 degrees? Okay, let's zoom in. Where on this circle will D be 30? Well, hopefully we see, hey, D is going to be 30 anywhere on this circle except for between A and B. As soon as it gets between A and B, it's no longer going to make a 30-degree angle. But everywhere else, it's going to make a 30-degree angle because it would be inscribed, it would be an inscribed angle of this arc 60, except for when it's actually on the arc. Okay? So, the real question is, what's the probability that D is on this portion of the circle and not this portion of the circle? Well, think about that for a little bit and see what you come up with. I'm going to put the answer on there in just a little bit, but I want you guys to pause the video and give it a try. See what you come up with. All right, go ahead and pause the video now. Okay, well, since I knew this was 60 degrees, I knew the rest of it was 300, because 300 plus 60 makes 360. So I put 300 degrees is all the times that it works out of a total of 360 degrees, and then I just started reducing. First I canceled out the zeros, giving me 30 over 36, then I pulled out a 6 of each, and I got 5 over 6. And that's actually the answer. The probability is 5 out of 6. And that's it. Alright, theorem 10.7 says that if an inscribed angle intercepts a semicircle, then the angle is a right angle. This is actually kind of easy to understand because we've been saying that inscribed angles are half of the arc. Well, what's the arc measure of a semicircle? It's 180, right? We learned that a while back. This arc measure here, we could say ADC as an arc measure equals 180. Therefore, the inscribed angle, which is angle B, should be half of 180 or 90. That's all we really need to know there, is that if it intercepts a half circle, it's going to be 90. So here I have triangle ABD and ADE are inscribed in circle F. So F is the center. With arc AB and BD being congruent, that's important, so let's mark it. Find the measure of each numbered angle if angle 1 equals 12x minus 8 and angle 2 equals 3x plus 8. Okay. Let's zoom in here first. Because you may be tempted to solve 1 and 2 first, but I think 3 and 4 are actually easier. So let's take a look. Angle B intercepts this arc, which is actually a semicircle. Semicircles are 180, so that means this inscribed angle must be 90. So I'm going to come over here. I'm going to mark that that's a 90-degree angle. Now, a couple other things I'm going to mark. I know that this arc and this arc are congruent, which means their corresponding chords are congruent. And now look, I have an isosceles triangle that's also a right triangle. And we learned a while back, a right isosceles triangle is always a 45, 45, 90 triangle. So we just found angles 3 and 4 without much work, just by remembering some of our properties. The next part, well, again, angle E here is still intercepting a semicircle, the other semicircle, but a semicircle nonetheless, so it must be a right angle as well. So, I'm going to zoom out a little bit. We're going to say, hey, that means that angle E plus angle 1 plus angle 2 should all add up to 180 because it's a right triangle. Well, angle E we already know is 90. Angle 1 we know is 12x minus 8. And angle 2 we know is 3x plus 8. All equals 180. And we're just going to do some algebra. Subtract 90. Subtract 90. Combine like terms. And we get 15x equals 90 because the 8's just cancel each other out. And divide both sides by 15, divide by 15, and we get x equals 6. All right, from here, all we really need to do is take this x equals 6 and plug it back in to both of these equations. So angle 1 equals 12 times 6 minus 8, while angle 2 equals 3 times 6 plus 8. So 12 times 6 is 72 minus 8. 72 minus 8 is 64. And then 3 times 6 is 18, plus 8 is 26. And there we go. We have found all the angles. There was 1 was 64, 2 was 26, 3 and 4 were both 45. All right, let's go on to the last page. Okay, last example here. It says, example number 4, quadrilateral ABCD is inscribed in circle P. So this circle over here is going to be our circle P. And it says angle B is 80, angle C is 40, find the measure of A and D. Well, let's just draw this out first, okay? Let's make this my A, B, C, and D. I know my drawing's not the best, but that's what it means. It means we have some quadrilateral looking something like this. And I know that AB and DC here look kind of like they're parallel, but they're not at all, okay? We don't have any information saying that, so I just kind of randomly picked these points here. And we know that angle B here is 80, and angle C here is 40, and we're supposed to figure out a way to find angles A and angles D. Well, here's the trick. If you want to try this on your own first, you should pause the video now, but I'm going to go ahead and explain it. It's this. This angle here is 40. Well, it's an inscribed angle. So that means that this arc over here has to be twice as much as 40, or 80. Well, if that's 80, then we should be able to find the rest of the arcs, which is just going to be 360 minus 80, right? So that's 280. So that means this arc over here in blue is 280, which then means that the angle that is inscribed and intercepts this blue arc here would be half of 240, or 280, sorry. I kind of wrote that kind of funky. Half of 280, or 140. And there we go. We found angle A. And now the last angle should be pretty easy to find. From here, we should be able to just say, well, we got three angles. We just do 140 plus 80 plus 40 plus angle D, because that's the one that's missing. All four of those angles need to add up to 360 because it's a quadrilateral. Well, 140 plus 80, that's 220, plus another 40 is 260. And then we just subtract 260 from both sides. And we get that angle D equals 100. All right, well, that's 100. And there we go. We found all the missing angles. What I want you to do is I want you to take a good look at that and see if you can't identify something about opposite angles inside a quadrilateral that's inscribed in a circle. Because take a look. Theorem 10.8 says, if a quadrilateral is inscribed in a circle, then its opposite angles are what? What do you think is going on here? Well, I see that 100 plus 80 is 180, and 140 plus 40 is 180. So, that means that they are supplementary. And there we go. All right. I want you guys to try this summary on your own. I'm just going to scroll it up here so you can read it. It says, draw a circle Q with quadrilateral WXYZ inscribed in it, and where WY goes right through the center Q. I'm going to kind of draw this with you guys. Let's say we had a circle, and we have W and Y going right through the center. Okay, this is important that you have this part here. But your actual quadrilateral is going to look something completely different, because here's your X, here's your Z, and now you have W, X, Y, Z. Okay? And I know that looks like a rectangle. I did not mean for it to do so. It is just a quadrilateral, okay? It could look like any quadrilateral. I did not mean for it to look like a rectangle. So, and then they say XYZ is 50. So this angle here is 50 degrees. And again, that's XYZ. And explain how you can find all the other angles. All right, have fun with that. I'll see you guys on the next video.